Hello everyone. The question that we are going to discuss today is the figure that has been given to you shows that there are two identical parallel plate capacitors A and B connected to a battery where the switch is closed. So you see the switch is closed. The switch is now opened. So initially the switch was closed, now it has been opened, and the free space, this free space between the capacitors have been filled with a dielectric of dielectric constant 3. So find the ratio of the total electrostatic energy stored in both the capacitors before and after the introduction of dielectric. Now let's take case 1. Case 1 is when we don't have dielectrics between the plates of the capacitor and the switch is closed. So the circuit is exactly this for the first case. Please keep in mind this circuit. Okay, this is for case 1. So let's first find the energy stored in the first capacitor. So the first capacitor, there are of course two formulas, half CV square and Q square by 2C. The formula that I am going to use is Q square by 2C. So Q square, let Q be the charge and the capacitor is C. So Q square by 2C, this is rather simple. Now even for the second capacitor, you see the charge is going to be same. The charge here also will be same. So Q square by, and since they are identical capacitor, both the capacitors are same capacitance, so the total electrostatic energy in case 1, let's term it as U initial, which becomes Q square by 2C plus Q square by 2C, which is nothing but Q square by C. Okay. So now let's move on to the second case. So case 2. Now to understand case 2 better, you have to first understand the circuit, because there are few notable changes in the circuit. So now the circuit looks something like this. This is the first capacitor, which is capacitor A. This is the second one, which is B. Now please note the circuit is open here, and this is the battery of V volt. Now please pay attention. You see that this capacitor A is connected to the battery, okay, because there is path for current to flow this way. So of course A is directly connected to the potential, but B is not connected to the potential because the circuit here is open. So B is not connected to the battery because the circuit is open. Okay, now the sum is simple. So for capacitor A, you see both have been filled with dielectric, but for A it is connected to the battery. So if it is already connected to the battery, it means what will happen to Q? So if it is connected to battery, that means potential will be same. What will happen to Q? It will become K times initial charge. So Q dash will become K into initial Q, which will be, since K is given as 3, so this will be 3Q. Okay, and what will be the capacitance? Again K times the initial value of C, Kc. So that will again be 3C. Okay. After that, so the energy stored, the final energy rather, or the energy for second case in A will be Q square by 2C. So Q square by 2C means Q dash square by 2C dash. So Q square will be 9 Q square by 2C, which will be 6C. Now for B, you see B is not connected to the battery. So for B, what will happen to Q? Q will remain constant. So you know that whenever whenever plates of a capacitor is filled with dielectric which is not connected to the battery, the charge will remain constant, because of course the potential will keep on varying though, but the charge will remain constant. So Q dash will be equal to Q, and if you look at C dash will change again as 3c. Okay, so what will happen to the energy? The energy will be q square by 2c. So q square by 2c means 6c. 6c. So that means the total electrostatic energy final will be UA plus UB. So that will be, see, this was 9q square by 6c, this is q square by 6c. So it will be 10 q square by 6c, which will be equal to 5q square by 3c. Okay. So now let us find out the ratio. The ratio will be U initial by U final. So if you see, the initial value of the electrostatic energy was Q square by C, and the final value is 5Q square by 3C. So this is Q square by C divided by 5Q square by 3C. So of course you cancel Q square, and C. So you will be left with 3 by 5, and the ratio thereby becomes, is to 5.